Hello, geometry friends. Here is the first video for Unit 5. It's about similar right triangles in trigonometry. So trigonometry is a branch of math that studies the relationship between angle measures in triangles and the lengths of their sides of the triangles. So in this unit, we're going to be studying trig, but we're going to only focus on right triangles, just the very most basic stuff of trig. Excuse me. So in this topic, we are going to learn about the three basic trig ratios. They are the sine ratio, the cosine ratio, and the tangent ratio. We're going to learn what is a cofunction and how they work, and then how in similar right triangles, the corresponding angles will always have the same side length ratio, no matter what the scale factor is. So first, we're going to learn about the trig functions with this link. Now, the link didn't work through Cami, but I will include it in the on Google Classroom as well. So it looks like this here. So this is sine, cosine, and tangent in a unit circle. So first, what we're going to see is just when you have a quadrant 1. Okay, so a unit circle means that you have a circle centered at the origin of the coordinate plane, and it has a radius length of 1. So you see in this picture, this is just 1/4 of the circle. It's just the first quadrant part of the unit circle. So imagine the circle would go all the way around, but notice how the length of the radius, the center of the circle is right here at the origin, 0, 0, and the radius is a length of 1. So when you have this, we can adjust the angle. So right now, there's an angle that goes from this point B to the origin up to this point C, and that is a 90-degree angle currently. Okay, and I can adjust the measure of that angle. Now, each of these are the different ratios. So SIN is short for sine. You're just missing the E. And then COS is for cosine, and TAN is for tangent. So right now, they're telling me that the value for the sine of this 90-degree angle is equal to 1. And the cosine of 90 degrees is equal to 0. And the tangent of 90 degrees is infinity. Okay, but watch as I adjust the angle. Now, see how a triangle develops in there, and how the values of each of these change when I change the angle. So again, trig is about studying the relationship between the measure of some angle and the length of the sides of this triangle that is formed in this. Now, if I just make this triangle bigger, if I just kind of dilate this triangle through the origin, then the ratio of these sides is going to stay the same as what it is when it's just on a unit circle. But the first thing we want to do is just kind of explore how these are related to each other. So you have the sine of 31 degrees is equal to 0.515. So when the angle is 31 degrees, you have the three sides of the triangle have a length of 0.857 is this horizontal length. 0.515 is this vertical length, and the radius is always 1. So no matter where I change the angle, the radius, the hypotenuse side, is always 1 because, again, this is on a unit circle. And as I adjust this angle, my horizontal and vertical sides lengths change, but the hypotenuse length is always 1. And what you notice is the sine of that angle is equal to 0.731 in this case, where 0.731 is the length of this vertical side. And the cosine is 0.682, which is the length of this horizontal side. So, and no matter where I adjust the angle, the sine is always the vertical side, and the cosine is always the horizontal side. Now, that's fairly obvious to see. The hard thing to recognize is what happens with this tangent length. My camera died again here. But what happens with the tangent length here? Where does this tangent thing come from? And that we'll look at very soon and define where the tangent is. But let's take a look back at this example. And here was one snapshot that I had from that screen where you have, so I ask you this question: where did the value for the sine of 50 come from in the diagram? So we look at this diagram and we see the sine of 50 has a value of 0.766. Where did that number come from? So again, that number is the length of this vertical side of this triangle. Okay, so sine of 50 is 0.766. This is the length of the vertical side of the triangle. Okay, now the next question, where did the cosine of 50 come from in the diagram? So the cosine of 50 is this number 0.643. Where's 0.643? That's the length of the horizontal side of the diagram. Okay, so cosine of 50 is 0.643. This is the length of the horizontal side of the triangle. So now let's take a look and find, use the link, or I'm going to click back over to find what the value for the sine of 40 is. So here I adjusted the angle measure in this link to 40 degrees, and the sine of 40 is 0.643, and the cosine of 40 is 0.766. So let me just pause and add them back in over here. So what's the value for the sine of 40? It was 0.643. What was the value for the cosine of 40? It was 0.766. Now let's compare. Question 5, I ask, how do sine 40 and cosine 40 values compare to sine 50 and cosine 50 from above? So when we look at these, the sine of 50 is 0.766 and the cosine of 50 was 0.643, but then I did the sine of 40 and that was 0.643 and the cosine of 40 was 0.766. So how do they compare? Is like this right here. So the sine of 40 is the same as the cosine of 50, and the cosine of 40 has the same value as the sine of 50. And there's a good reason for that, because here is how this works. Okay, so when we have this right triangle, see I have a little right angle symbol here. I'm looking at this angle right here, so where I have the angle marked. So from this as my angle, there's three sides that I'm labeling this triangle. Well, of course, when this angle right there is the right angle, this side over here is called the hypotenuse, okay? And then this OPP is short for opposite. Opposite means this is the side length opposite of this angle that I'm measuring right here. And then this side down here is ADG, that's short for adjacent. And so how it works is the sine is not only the length of the vertical side, the side opposite of that angle, it's actually a ratio. It's a ratio of the opposite side with the hypotenuse. So if you look close, like what do I mean by ratio? Well, see here, the sine of 50. This opposite of 50 degrees is the vertical side. See, if this is my angle, that they're calling it this Greek symbol beta, the Greek letter beta. If this is the angle beta, this is the side opposite of that angle. And the side opposite is the 0.766, but that's in a ratio with the hypotenuse length 1. But what happens when you divide any number by 1? You get the same number again. So the ratio for sine 50 is actually 0.766 divided by 1. But since it's divided by 1, it just stays at 0.766. And the cosine ratio is the ratio of the adjacent side with the hypotenuse. So again, so this is 0.643 divided by 1, which is again just 0.643. So the sine of an angle, the sine is a ratio or a numeric comparison of the side opposite of the angle to the hypotenuse. And the cosine is the side adjacent to the hypotenuse and adjacent to the angle and the hypotenuse. And then the last one, tangent, we haven't talked about yet, but tangent is a ratio of the opposite of the angle with the adjacent side. Let's take a look at that on my application now. So the tangent here, they say, is the ratio of the side opposite with the adjacent side. So if we were to look and investigate this, see how the length t here is, the tangent of 40 is this length 0.839. So it's the distance from this point t to this point b. And as I adjust that, that's where that length comes in. So here you can see that no matter what I do, as I move this around, the length from t to b is the length or is the value for the tangent of the angle in this unit circle. And if I look at this on a calculator, again, it's the ratio of the opposite side to the adjacent side. So if I put a ratio of 0.809 over 0.588, let me take a look at that here. I'm going to do 0.849 divided by 0.588. And as I calculate this difference, 0.849 over 0.588, you get this number 1.44. So when you have, oh, I typed the wrong thing in, 0.809. Let me try that, 0.809. Okay, this time, if I type in 0.809 over 0.588, you get 1.375, which is essentially what we have right here, if I were to round it appropriately. Okay, but that's what the tangent is and where that value comes from. So that each of them represents a ratio of two sides of the triangle. And when you're on the unit circle, then it happens that the sine value is just the vertical length and the cosine value is just the horizontal length, because you're dividing each of them by 1. So again, the sine is the ratio of the side opposite with the hypotenuse. So as you can see here in the summary, the sine of this, now see this symbol right here is a Greek letter. It's called theta. And theta is a very common or typical way that we symbolize some angle. So the sine of theta is equal to the length opposite over the hypotenuse of a right triangle. The cosine of theta is the adjacent side over the hypotenuse, and the tangent of theta is opposite over adjacent. So those are the three trig ratios. Sine is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, tangent of the angle is opposite over adjacent. So that's step one, knowing what the three basic trig functions are. The second thing is about cofunctions. So let's talk again about cofunctions. Let me write something in here. So sine and cosine are called cofunctions. When the two angles are complementary means that they add to 90 degrees, then the sine and cosine of those angles are equal. So like we saw above, the sine of 40 is equal to the cosine of 50. Or the cosine of 30 would be equal to the sine of 60. Why? Because 30 plus 60 is 90. 40 plus 50 is 90. And if I was going to go with a very generic case like this over here, you see the sine of x is equal to the cosine of 90 minus x, because x plus 90 minus x is equal to 90. So that's what a cofunction is. It's these two functions, sine and cosine, are cofunctions, and when the angles are complementary, they have the same value. We'll look at that more down here below. So in this example, it says triangle ABC is the image of triangle DEF after a dilation. So if ABC is the image of triangle DEF, that means that triangle DEF was the pre-image, and ABC is the image. And we want to identify the scale factor. Well, if the scale factor, if these side lengths are going from 6, 8, and 10 to 3, 4, and 5, then the scale factor is the ratio of an image length over the pre-image length, which you can see that in this case is a 1:2 ratio. Okay, so the scale factor would be 1/2. And so if I was going to write my corresponding sides in proportion, it looks something like this. So the corresponding sides in proportion would something like AC corresponds to DF, and CB corresponds to FE, and then AB corresponds to DE. Okay, now here is another way of looking at trig ratios. Okay, so this time it says determine the value of the following trig ratios. Sine A. Sine A means I'm going to treat A as the angle. So I'm going to go up here and say, okay, so if A is my angle that's right here, that means that from this, here is my hypotenuse on this side. I'll label that HYP for hypotenuse. This is the side opposite, and this is the side adjacent. Okay, and so I want to find the ratio for each of these different angles from cosine, or from using the angle A. Okay, so when I say the sine of A, where A is my angle, the sine of A is the side opposite over the hypotenuse. So the sine of A would be the ratio of the side 3/5. So in this case, the sine of A is not simply the length of the vertical side, because it's a ratio of the vertical side with the hypotenuse. And in this case, the hypotenuse is not equal to 1, so it's 3/5. The cosine of A is the side adjacent over the hypotenuse. Again, cosine is adjacent over hypotenuse. So cosine would be the length of the side 4/5. And then the tangent is the side opposite over the side adjacent. So the side opposite is 3, the side adjacent is 4. Okay, so here's the sine of A is 3/5, the cosine of A is 4/5, and the tangent of A is 3/4. Now, when I look at my sine of D, cosine of D, tangent of D, this time I'm going to look at it as D being my angle that I'm referring everything to. So from angle D, this is the side opposite. Here is my hypotenuse. Oops. And here is my adjacent side. Okay, so the sine of D would be the length of the side opposite angle D, which is 6 over the hypotenuse 10. But like I said, that these triangles are similar to each other. We know that the triangle ABC is the image of triangle DEF after dilation with a scale factor of 1/2. So even though that these triangles are similar, the ratio of this angle would be still 3:5. So even though the side lengths are bigger, the ratio is still the same because this angle A is congruent to this angle D. They are corresponding angles, and so they're congruent to each other. The cosine of D is the side adjacent to angle D, 8 over the hypotenuse with angle D, 10, which again, 8 over 10 is the same thing as 4 over 5. So the lengths change, but the ratio is the same. And then the tangent of D is the side opposite 6 over the side adjacent 8, which is still 3 over 4. So the last point that I wanted you to learn was how when a triangle is dilated, the ratios will still stay the same because the angles are the same. The ratio of the opposite and hypotenuse, or opposite and adjacent, or adjacent hypotenuse, those ratios are always going to be the same no matter what the size of the triangle is. Okay, and one last point I want to make is take a look at this down here. If I want to investigate what the sine of C is, or the cosine of C, or the tangent of C, then I'm going to look at this and I'm going to reestablish my sides according to angle C. So what I'm going to do is I'm going to rewrite this, and this time, if C is my angle up here, now the hypotenuse is still the hypotenuse, but now the side opposite of angle C is down here, and the side adjacent to angle C is over here. So when we talked about cofunctions before and how the ratios just kind of switch, it's because when you switch these angles, the opposite and the adjacent sides just switch. So what is the sine of C? The sine of C is the side opposite of C, that's 4 over the hypotenuse. So it's 4 over 5. And the cosine of C is the side adjacent to C. Adjacent to C is 3 over the hypotenuse is 5. So this is 3:5. And then the last one is the tangent of C, and that's the ratio of the opposite side over the adjacent side. So it's 4 over 3. So again, one last time when we're looking at cofunctions, you see what we had right here. The sine of A is the same as the cosine of C, because angle A and angle C must be complementary angles. This angle A plus this angle C have to add up to 90 because angle B is also 90. So since that's 90, then these two angles must add 90 because the triangle angle sum is always 180. So complementary angles have the cofunctions are always going to have the same value. The sine of A has a value of 3/5. The cosine of C also has a value of 3/5. And then you see that here with the cosine of A and the sine of C. Okay, so that is our first lesson about trig. Now we know what the 3 basic trig functions are. We have heard about cofunctions and how they work. And we saw when triangles are similar, the corresponding angles will always have the same side length ratio, no matter what the scale factor is. Bye-bye.